Hi students, another session of physics from Raju and PSK classes. We are in semiconductors, and I said as in the last class that we are going to discuss about an amazing device that changed the world, that gave a lot of freedom to electronics. 1947, India got its freedom. 1947, in America, Bell Laboratories designed and produced a tiny device called transistor, which gave freedom to electronics. After that, the field of electronics industry flourished like anything. Whatever you see around you now, thanks to this small device. It's an amazing one. Okay, it's called bipolar junction transistor, BJT. You can see the small diagram here. It's a very tiny device with the three connecting terminals, these three connecting terminals. Transistor is a 3-segment, each of these wire goes to a segment, 3-segment, 2-junction device. 3 segments, 2 junction. Used mainly for two things. One, to amplify weak signals. Second one, it is working as a switch. Every time you use a computer, mobile phone, millions of transistors are changing their voltage levels. That change in voltage level is what we call a switching operation. So the moment I take and turn on the screen of my mobile phone, millions and millions of transistors are here inside working. Every time you store something, every time you use internet, millions of this thing is working everywhere in this world. It's a network of electronics. What are the different segments of transistor called as? One is called emitter, second one is called base, and third one is called a collector. Now about doping. The emitter is heavily doped, base is lightly doped, collector is moderately doped. About physical size. Collector largest in size, base smallest in size, emitter moderate in size. Read on. 3 different segments. Their doping concentration, the physical size, etc. should be understood. Okay. Emitter is heavily doped because it produces large number of electron and holes for the working of this transistor. Now, these are the 2 types of transistors that we are going to discuss. One is called PNP, another is called NPN. And a PNP transistor, 3 segments, P segment, N segment, P segment. NPN, N segment, P segment, N segment. 3 connections, emitter, base, collector, emitter, base, collector. This is how you write the symbol of that one. This is a symbol of NPN, symbol of PNP. And this is a practical device. Types of transistor. NPN means 2 segments of N-type semiconductor. In between there is a P-type semiconductor. PNP means just opposite. Don't worry, more detail. This is an NPN transistor. N-type semiconductor and N-type semiconductor separated by a very thin P-type semiconductor. This is called emitter, this is called collector. Collector is a bit larger than emitter and base is very, very thin. This is the other one, PNP transistor, NPN and PNP. Okay. Now, when you draw the symbol, how to draw their symbol? Normally, an NPN transistor is represented by 3 lines like this. These 3 lines represent 3 segments, 1, 2, 3. And there are 2 junctions, one junction here, another junction here. 3 connecting wires, one connecting wire here, another connecting wire say here, another connecting wire here. The central one is called the base. One of them is called collector, other is called emitter. But how do we know that one? Which is collector, which is emitter? Then, for that we use an arrow mark in the emitter terminal. The arrow mark shows that is the emitter. It won't be written. It will appear like this one, which is the emitter. First you observe emitter, the arrow mark shows it is emitter. then the other one is collector, and in between one is base. So this is emitter, this is base, and this is collector. Now the other transistor, again same method, base, collector or emitter, and the third one, which is emitter. You need an arrow mark, but you have to say one is NPN, another is PNP. So we simply put the arrow mark in the reverse. NPN, PNP. This become base, this is collector, this is emitter. Okay. Jokingly, this can confuse you. കുറച്ച് കഴിയുമ്പോൾ നിങ്ങൾക്ക് കൺഫ്യൂഷൻ ആവും. ഇതിൽ ഏതാണ് NPN, ഏതാണ് PNP എന്ന് കൺഫ്യൂഷൻ വരും. അപ്പോൾ കൺഫ്യൂഷൻ മാറ്റാൻ ഒരു ഐഡിയ ഉണ്ട്. എന്താണ്? ഈ ആരോ മാർക്ക് പുറത്തേക്കല്ലേ, ഔട്ട്വേർഡ് ആണ്. ഓക്കെ, എന്ത് ട്രാൻസിസ്റ്റർ ആണെന്ന് വെച്ചാൽ നോക്കൂ, പുറത്തേക്ക് നോക്കൂ. NPN നോക്കൂ, പുറത്തേക്ക്. ഇഫ് ദ ആരോ മാർക്ക് ഈസ് ലുക്കിംഗ് ഔട്ട്വേർഡ്, ഇറ്റ്സ് എ പുറത്തേക്ക് നോക്കുന്ന ആണ് NPN. സോ വാട്ട് അബൌട്ട് ദിസ് വൺ? ദിസ് ഈസ് പുറത്തേക്ക് നോക്കാത്ത പാർട്ടിയാണ് PNP. ബസ്. So be like confident about the symbol. Fine. You don't have to, like in examination they may confuse you with these notations, symbols. So two type of transistor, emitter base collector, details, symbols, NPN and PNP. Now biasing. Biasing means giving voltage. You know, every transistor has got two junctions. One is called the collector base junction, another is called the base emitter junction. Collector base and emitter base. Two junctions. How are they biased? To operate transformer positively, the emitter base junction, emitter base joining point is forward biased and the base collector is reverse biased. Keep that in mind. Emitter base forward, collector base reverse. Then only it is active, otherwise it will not work. Okay. Let us discuss about the working of a transistor. For that you need to understand clearly the working of a PN junction, because transistor is basically PN junctions, two PN junctions. How to forward bias this PN junction? Forward bias means P must be higher potential. This should be at a higher potential, show it by the plus sign. N should be a lower potential, show it by a negative sign. Then what will happen? Then electron from there will come here, holes from here will go there, and current will flow in this direction. And electrons are majority in N side, holes are majority in the P side. So we can see that in a forward bias junction, which carrier will cross? Which carrier will cross? Understand, majority carriers will cross the junction in forward bias. What will happen if it is reverse biased? If it is reverse biased, this is negative, this is positive. Then, due to the electric field, holes from the N side will cross, electron from the P side will cross. Okay, holes from the P side will move away, electron from the N side will move away. So we should understand that. Listen carefully. When it is reverse biased, electrons from the N side, electrons are minority, will cross. Holes in the N side, which are minority, will cross. So we can see reverse biased means minority will cross the junction. Forward bias means majority will cross, reverse bias means minority will cross. If you know this, it's very easy to study the working of a transistor. Biasing. Let us understand biasing and the few general notations. This NPN transistor, you need to bias it. Bias means this is the emitter base junction. This junction must be forward biased. So this PN junction should be forward biased. That means P must be at higher potential positive, N must be at lower potential negative. Okay? This junction is called the base collector junction, should be reverse biased. For reverse biasing, N should be at higher potential and P should be at lower potential. So that is correct. PNP, PN junction. PN should be forward biased emitter junction. So this should be connected to positive, this should be connected to negative. This should be reverse biased. So this P should be connected to negative and N should be connected to positive. Okay. In fact, these connections can be done separately. One connection here and one connection here, but we combine them to a single connection, that is it. Fine. Now, the way we call these batteries, their names, see that the battery which connects to emitter, the battery which connects to emitter is called VEE, VEE. and the battery which connects to collector is called VCC. VEE and VCC. And the base connection goes to this VEE and this VCC commonly. So we will say this is a common base connection. Common base connection. Both of them common base, which is not there in our syllabus. But working is easy with this common base. Okay. So my points are simple. Forward bias, the emitter base junction, reverse bias, the collector base junction, called VEE, VCC. Okay. If there is a battery connected here separately, they will be calling it as VBB. Okay, wait. That will do later. Okay. Now working of transistor, important theory. You can see that this is an NPN transistor. This is forward biased, this is reverse biased. This is a forward biased junction. In a forward biased junction, what will happen? Majority carriers will cross the junction. And what are majority? N-side electrons. Okay. Read this. Electrons which are majority carriers in the emitter. Look at the diagram. Crosses the forward biased emitter base junction. Okay. And reach the base region. Base is a p-type metal, semiconductor, and electrons are minority in the p-type. So those electrons which are majority in the n side reach the p side. That's what we call as minority carrier injection. Now here they are minority. Now when they come here, they see another junction, and that junction is a reverse biased one, and reverse biased minority can cross. So electrons are happy here because they are majority, they can cross the junction. They are happy here because the next junction is reverse biased, they can cross. Same electron can cross. So electron can cross this junction because they are majority, and the next junction because they are minority. Okay. Electrons which are majority here will cross the junction, and electrons from the battery will come and occupy this region. From here electron will come, and that will produce a current in the opposite direction, which is called emitter current. How emitter current is produced? First statement, electrons which are majority in the emitter crosses the forward biased emitter base junction and reaches the base. Electrons from the supply VEE move to the emitter and produce the emitter current, which is in the opposite direction. That part is over. Next one, small number of electrons reaching the base. See here in the base there are holes because it's a p-type semiconductor, and so many holes, so many electrons are coming, and there are few holes, so some of this electron will combine with the hole and they are lost. Remaining electron will go to the collector. Listen, a small number of electrons reaching the base recombines with the holes in the base. Okay. Electrons from the base region flow to the external circuit. From this base circuit, electron will flow outward, which will produce a current into the base. That's called base current. That's how base current is produced. How base current is produced? Few electrons will combine with holes in the base region. Okay. And holes will be from the, see, if you want a hole, you need an electron separation, and that separated electron will go outward, this electron will combine. So this will produce base current. And see the direction of base current. What will happen to the electrons reaching here? See this. The remaining electrons which are minority carriers in the p-type base crosses the reverse biased base collector junction. They reaches the collector. Electron from the collector, these collectors, they will go towards this positive terminal and they'll produce a current in the opposite direction. So three currents are there. One is electron, one is emitter current, second one is base current, third one is a collector current. Okay. Now if you use Kirchhoff's current law, you can see that there are two currents going into the transistor. One, two, and one coming out. So you can make an equation, the outward current I equal to the incoming current IC plus IB, i.e. emitter current is the sum of base current and collector current. But you should see that the base current is due to few electrons. Base current is always very small, collector current is a little high, emitter current is the sum of these two, so that will become the highest current. Working, 3 sentences. Mechanism, draw the circuit, study it. Okay. Suppose the same thing is asked about PNP transistor, we say more or less the same thing. This is the diagram from NCERT, this is the simplest diagram. Okay. Simplified diagram, not simplest, simplified diagram. Same thing you can see, this is a P-type, N-type, P-type. Holes are majority, holes are minority. Forward biased, reverse biased. You can use the same sentences. Holes which are majority in the emitter crosses the forward biased emitter base junction. Electron from the emitter moves to the battery and produces the emitter current. You should know that the emitter current is now flowing into the device. In the other one, emitter current was going out of the device. A small number of holes reaching the base recombines with electrons. Electrons from the external circuit flows to the base. In the previous case, electrons was flowing from the base to the outer circuit, that's why current was into the device, but here electrons are flowing from external circuit into the base, so current is in the opposite direction. The remaining holes, which are minority in the N-type base, will cross the reverse biased base collector junction. So when holes are here, electron from VCC will go into the device and they will produce a current in the outward direction. So there are again 3 currents here, emitter, collector and base. Apply Kirchhoff's current law. There are 2 currents coming out, 1 current going in, so that should be equal. I equal to IC plus IB is applicable. So whether it is NPN or PNP, the equation for current is same, only the direction is reverse. Now I will come and tell you, see, watch out. In a PNP, emitter current is into the device, PNP. In the NPN, it is out of the device. That is what we used in the symbol. NPN, emitter current flows out of the device. In PNP, it will flow into the device. That's why these arrow marks. Okay, so here you can see emitter is flowing out, base will be into this device, collector current will be into the device. Here emitter is going to the device, so base current must be out of the device, collector current also is out of the device. Out of this, base current is very small than collector current or emitter current. Emitter current is the highest, then comes collector current, then comes the base current. So this is the working of transistor. Now transistor, there are 3 configurations. Basically there are 3 configurations for transistor. These are known as common base configuration, common emitter configuration and common collector configuration. In the beginning I said something about common base. The base terminal connects both emitter and collector, that's why it's common. Our syllabus is only about common emitter configuration. We don't have to worry about these 2. The common emitter circuit is the most often used and most widely accepted one and with the highest amplification. Common emitter configuration can be drawn like this. What transistor is this? NPN or PNP? Noku pratyekku noku. So this is NPN. You can see that this is the base, this is collector, this is emitter. Emitter has got a connection towards the input side and output side. Input is between base and emitter. Output is between collector and emitter in both the cases. This is common emitter. Emitter is common. Okay. When emitter is common, the battery that we connect to the base will be called VBB. And the battery we connect here will be called VCC. There is no particular name for anything here. So common emitter, there are 2 battery, one is VBB, another is VCC. We studied about a characteristic of a diode, you remember that. Similarly, we have characteristic for transistor also. Common emitter characteristic of transistor, which is only the relation between voltage and current. You give a voltage, find out the current, draw a graph. There are two types of characteristics. One is called input characteristics, another is called output characteristics. Yes, input and output. Okay, here this is a circuit arrangement for finding the input characteristics. Fine. We can see that there is a transistor. Okay. This is a common emitter configuration. There is an ammeter here in the base circuit to measure the base current, and there is a voltmeter here to measure the voltage between base and emitter, VBE. There is a voltmeter here to measure it between base, collector and emitter. Collector and emitter. There is a ammeter here to measure collector current. There is a resistance in the outer circuit. There is voltage in the outer circuit, VCC. Inside here, input, RB is the resistor, and there is a battery connected, VBB. Okay. Practically, circuit is simple. Like here, all the devices are marked. That's why it is complicated. If the devices were eliminated, then you have your transistor. You see, even that circle is not required for the transistor. Only this much is sufficient. This is the base. In the base, you put a resistor, and this is called resistance in the base, RB. And the voltage, you can see the base is connected to the positive here. This battery is called VBB. And the collector go through a resistor, then another battery, a little stronger one. And that's, you should easily see this point, that these two negatives are commonly connected. So the polarity doesn't change any. Okay, this is negative, that is connected to the emitter. Emitter is NPN. If it is PNP, what to do? If it is PNP, this should be reversed, this should also be reversed. That's it. Now, which are the currents flowing? Emitter current is flowing outward, I emitter. Base current will flow in, this is called base current. Collector will also flow into the device. Collector current also will flow into the device, this is called IC. Okay, and what you want? You want to measure the base current, so you put an ammeter there. If you want to measure this current, you put an ammeter. If you want to measure this current, you put an ammeter. If you want the voltage here, you put a voltmeter. If you want the voltage here, you put a voltmeter. So the circuit is over. Now you can vary this, that's it. This can also be varied. Because by varying the voltage, the current will vary, you can plot a graph. By varying this voltage, this current will vary, you can plot a graph. If you vary voltage and current here, this side, this is called input characteristics, and if you do that here, it's called output characteristics. Simple. Now we'll study about the input characteristics in detail. So, how to draw input characteristics? First of all, what is the meaning of input characteristics? Listen carefully. Input characteristics means it is a graph between voltage and current. This voltage is called VBE and this current is called IB. What is a VBE? Voltage between base and emitter, the reading of this voltmeter, and IB is the current in the base, reading of this voltmeter. We have to find out different currents for different voltages. That's what we do. Fine. Now for this, what to do? You apply a battery here, then you vary this voltage. When you vary this voltage, this will vary and the base current will also vary. And you should know that this is happening across base and emitter, and you know base emitter is a forward biased PN junction. So no doubt you will get a graph like this, exactly like a PN junction diode. The input characteristic of a transistor is exactly like the PN diode characteristics, because the input side emitter base is forward biased. So you get a graph like this one. That means up to certain value no current, beyond that there is a large current. This value can be like a 0.6 volt for silicon, 0.6 or 0.7 for silicon, and 0.2, 0.3 for germanium. If you find out slope here, you can get the resistance, just like you did in diode, resistance. And you can see that the resistance, there is a large current, resistance is less. Input resistance is less. The slope of this one gives you the resistance in the input, which will be a small resistance. Okay. But one condition is this. What is that? Whenever you do this experiment, this voltage should remain constant. Which voltage? The voltage between collector and emitter should remain constant. So define input characteristics. Input characteristics is the variation of, where is that? It's not given here, maybe missing. Input characteristics is this one. It is a variation of the base current with the base emitter voltage at a constant collector emitter voltage. What should be kept constant? The collector emitter voltage should be kept constant. Then you vary this. Then find out the variation. Okay. Now we can see that VB is increased in suitable steps and the corresponding base currents are noted and you draw a graph. When the base voltage is less than 0.6 volt here or 0.3 for germanium, there is no current. Current flows only when it is more than 0.6 or 0.3. Okay, that's an important point. So I'll tell you what to memorize for further discussion. That is this point. If the base voltage is less than 0.6, there is no base current. Base voltage less than 0.6, there is no base current. For base current to flow, the base voltage should be more than 0.6. If you increase the base voltage, what will happen? The base current will also increase. Okay, so these 2 points should be memorized for later usage. First one, VBE less than 0.6, base current equal to 0. VBE more than 0.6 and increases, what will happen? Then you should know base current increases. ഇത്ര മാത്രം. 2 പോയിന്റ്. ബേസ് വോൾട്ടേജ് ലെസ് ദാൻ 0.6 ആണെങ്കിൽ ബേസ് കറണ്ട് 0 ആയിരിക്കും. അത് സിലിക്കൺ ആണെങ്കിൽ. ബേസ് കറണ്ട് ഗ്രേറ്റർ ദാൻ 0.6 ആണ്, പ്ലസ് ഇറ്റ് ഈസ് ഇൻക്രീസിങ്. What will happen to the base current? The base current, you can see 0.6 here, more than 0.6 and increasing, the base current will also increase. But that is only in microampere, very small current. Base current is microampere. Okay. Now you can define the resistance. The input resistance, that part is missing. Okay, something happened to that one. Anyway, input resistance is defined as the ratio of the change in the base emitter voltage to the change in the base current at constant collector emitter voltage. This definition should be clear. And you can see that the value is not very high, few hundred to few thousand. That is the value of the resistance. Okay, so the input resistance and the ratio, the slope, everything is discussed here. Now what we have is the output characteristics that we will do in the next class.